In this video, we are going to go through the 4.2.2 learning target focused on multiplication this time. So we already talked about addition and subtraction. And for multiplication, we actually have two different methods, and I'm going to teach both of them, and then you can kind of choose which is your preference. Same thing with last unit, like how you could choose between substitution and elimination to solve systems. It's similar, like you can choose the method that makes the most sense for you every time, or you can like choose based on the problem, so switch it up. But the general idea is that when we're multiplying polynomials, we multiply every term in the first polynomial with every term in the second. So it's basically like distributing multiple times. So you distribute everything in the first to everything in the second. If you need a second to write that down, you can pause this. And now we're going to go through an example of both methods. So the example says find the product of the polynomials. And we do need to make sure we know like what these vocab words mean. So product means multiply. Remember, sum means addition and difference means subtraction. So when we find the product, we are multiplying our polynomials. And then we have these two methods. So the distributive method and the box method. The distributive method is sometimes called FOIL. So if you remember FOIL from middle school, it's sometimes grouped under the distributive method. The only reason we don't describe it as FOIL is because FOIL only works if you have polynomials this size. So there's two terms and then two terms. But if you get any bigger or any smaller, FOIL doesn't make any sense. So we don't call it FOIL, we call it distributive method because that works for every polynomial. But if you heard of FOIL, that's what this is. So the distributive method, the first thing we want to do is we want to write these in parentheses next to each other so that we can represent the product part, the multiply part. And so now basically what we're doing is we're going to distribute, hence the name distributive method, every part of the first to every part of the second. And how this works is I always start with the first term and then distribute to everything in the second, and then keep going. So the 3x times the negative 4x. And remember, when we are multiplying our terms, we are actually going to add our exponents. So we multiply the numbers out front, so 3 times negative 4. And then you're going to add up these exponents. So I have 1x and 1x, that makes 2x's, so x squared. So whenever you're multiplying, you want to add your exponents. So now I go back to this first term and I distribute again to the next term. So 3 times 7 gives me a positive 21. And then there's 1x here and none here, so I just have 1x. Now you're going to go back to the next part and you're going to distribute that one. So I'm going to distribute minus 12 times negative 4x. Well, negative times a negative is a positive, and 12 times 4 is 48. And I have no x's and 1x, so I have 1x. And then again, distribute again, minus 12 times 7. I don't know that off the top of my head, so I'm going to type that in. Negative 84. And so now you can see like the 3x has been distributed to both, and the negative 12 has been distributed to both. So you want to make sure that every part in the beginning is distributed to every part in the second one. And now you just want to clean up your answer. So combine any like terms, reorder it in standard form if you need to. Most of the time your like terms are going to be in the middle. So you can see I have those two like terms. Going to add these together to get 69x and then minus 84. So now you can see I have no like terms left, and I have my answer in standard form. So this is the distributive method where you can distribute your terms. Now there's another method. I'm going to do the exact same problem with the box method. And again, you can choose which one you like better, or sometimes it makes more sense to do distributive versus box, and I'll show you when. But for the box method, like it says, we are going to draw a box, and that box is going to be the same size as our polynomial. So it needs to have the same number of rows as one of them and columns as the other. This one's pretty easy because this has two terms and this has two terms, so our box is going to be a 2 by 2. So I'm going to draw a box with 2 columns and 2 rows. And you want to make sure your box is big enough that you can write on the inside of it. And then you're going to place your polynomials on the top and the left, kind of lined up with this. It's kind of like a Punnett square in biology. So you're going to have like the outside parts, and then you're going to multiply to get the inside, or combine to get the inside. That's exactly what we're doing. So it doesn't matter if you put this one on the top or the left, but we want to match up the terms with the rows. So I have 3x and then minus 12. And then minus 4x and plus 7. So you can see how they like line up. And now what we're going to do is we're just going to multiply every row and column. It essentially does the exact same thing as this in a different way. So we're going to multiply 3 times negative 4 to get negative 12, and then add your exponents. 7 times 3 to get 21, and then we have an x. Negative 4 times negative 12 to get positive 48, and we have an x. And then 7 and negative 12 to get minus 84. So now I have all my pieces of my box. This is not my answer. I need to make my answer look like this. So I need to pull it out of the box. And so I like to find my like terms inside the box and combine them, so I don't have to like pull it out and then combine like terms. So these are my like terms, but I have negative 12x squared plus 69x minus 84. And you can see we get the exact same answer, which is a good sign. So the distributive, you distribute each piece, you draw a lot of arrows. The box, you draw a box, put them on the outside, and multiply to get the inside. Now for ones that are a 2 by 2, so 2 terms and 2 terms, it's pretty equally easy to do each of these methods. The box method starts to come in handy when you start to get bigger. So as you have polynomials that look like this, you can imagine that I'm going to have to draw 2 arrows, and then 2 arrows, and then 2 arrows. So I have 6 arrows now, so it's starting to get a little bit complicated. The distributive method still works, it just might look a little crazy. So if you want your work to be a little more organized, I suggest using the box method for anything bigger than 2 terms. And you just got to make your box the right size. So I need 3 either rows or columns. So you have the choice to draw your box like this, where there's 2 rows and 3 columns. Or you can draw your box like this, where there's 2 columns and 3 rows. Doesn't matter. You just want to line up the one with 3 with the side that has 3. And so you can see this would be the difference between the two, but you'll get the exact same answer. So I'm going to do this one, and again we're just multiplying each one. Just be really careful when you add your exponents. I like to draw on my 1 so I don't forget. So 3 times negative 3 gives me negative 9. I have 3 x's and 1 x, so that gives me x to the 4th. Negative 2 times negative 3 is a positive 6. I have 1 x and 1 x, so I have x squared. 4 times negative 3 is negative 12, and I just have the 1x. 3 times negative 6 is negative 18, and I have x to the 3rd that I need to bring with me. Negative 2 times negative 6 is a positive 12, and I have the x that I need to bring. And 4 times negative 6 is negative 24. So now again, I want to identify my like terms inside the box so that when I bring it out, I can combine everything and put them in order. So highest exponent to lowest. Negative 9x to the 4th minus 18x to the 3rd plus 6x squared. Positive 12 and negative 12 cancel. So I don't even need to write those down. And then minus 24. So this is my answer. And I just wanted to show you one that's bigger so you knew how to draw the box. But I suggest anything bigger than 2, you use box method. Anything smaller, you use distributive. But again, they both work for all polynomials. One just might be a little bit easier than the other.